Good evening, students. Today we come to discuss preocular telephone. Preocular telephone. What is it at all? Remember that on the surface of your eyeball, there is always a fluid, a liquid, which makes movement of the eyeball and the eyelids on the ocular surface become smooth. And this fluid is known as what? Telephone. Telephone. All right, the telephone. People also call it meniscus or telephone. All right. Okay. So that is it. When you find it, so the whole ocular surface made up of the cornea and the conjunctiva. So we call it what? Preocular telephone. If you are referring to only the one on the cornea, then call it what? Precorneal telephone. All right. But in total, we can call it meniscus or telephone. All right. Good. That is it. How much of it do you usually have on your eye in under physiological conditions? You have between 7 to 10 microliters on the surface of the eyeball under physiological conditions. Okay, great. So remember that all what you have here is just demonstrative. Okay, in actual sense, it is a film. Okay, the thickness of it is just about 7, or the volume of which is just about 7 to 10 microliters. So it is just around this area, but it has been expanded just for your personal understanding. So there are three basic layers of the telephone which is found on the ocular surface. Three basic layers. Okay, so assuming the cornea is up to this area, all right. So this is the cornea is up to this section, all right. So from this area all over to this surface is known as what? The telephone. It has three major layers. We have the inner mucin layer. This is it, the inner mucin layer. All right. The middle aqueous layer, which constitutes about 90% of the thickness of the telephone, and of course, the surface lipid layer or the outer lipid layer. So, outer lipid layer, the middle aqueous layer, and then the inner mucin layer. So the mucin layer is in direct contact with the cornea and then the conjunctiva, right? Whilst the lipid layer communicates straightforward with the atmosphere, and of course, when we blink with the palpebral conjunctiva. So, what are the sources of these layers of the telephone that we have been talking about? Where are these layers produced from? Okay, okay. So let us start from the mucin layer. The mucin layer. Okay, where is it from? Number one, it is produced by the goblet cells of conjunctiva. So the mucin layer is produced by the goblet cells of conjunctiva. Okay, and we said in our previous lectures that the goblet cells are in their highest concentration at the infranasal part of the conjunctiva. Another source of the mucin layer is from the lacrimal glands of Mans and Henle. There are certain ancestral lacrimal glands that we call what? Mans and Henle. So they also help in production of what? Mucin as part of the telephone. Again, we have superficial epithelial cells from conjunctiva and cornea. So superficial epithelial cells from cornea and conjunctiva also produce what? Mucin layer. But among them all, the most significant is the goblet cells. But remember, there are three major sources: the goblet cells from the conjunctiva, accessory lacrimal glands of Mans and Henle. The last but not the least is what? Superficial epithelial cells of conjunctiva and what? Cornea. They help in production of what? The mucin layer. Okay, now let's talk about the aqueous layer. The aqueous layer. What is the major source of the aqueous layer? It is produced by one, the main lacrimal gland that we have spoken about in previous lectures. Okay, produced by the main lacrimal gland here. All right. We also have accessory lacrimal gland. Okay, of Cross and Wolfram. So we have the main lacrimal gland and of course accessory lacrimal gland of Cross and what? Wolfram. So these are the two major sources of what? The aqueous layer that constitutes the preocular terraform. Okay, now let's talk about the most external layer, which is what? The lipid layer. The lipid layer. So, where do we get the lipid layer from? If you remember in our previous lectures, we said that the tarsal plate of the eyelid has what? Meibomian glands. Okay? And at the level of the eyelashes, we have glands of what? Zayas and gland of mole. So the major sources of the lipid layer are one, the meibomian glands found in the tarsal plates. Okay? Two, gland of Zayas. And three, gland of mole. So meibomian gland, gland of Zayas, and gland of mole. These are the three sources that help in production of what? The lipid layer. Okay, so we've spoken about their sources. Now, let's talk about chemical composition of terraform. The chemical composition or the chemistry of what? Of terraform. All right, so let's start with the lipid layer. Okay, the lipid layer. So basically, the lipid layer, what does it contain? It contains lipids. Okay, basically lipids, triglycerides. So that is the major substance that the lipid layer contains. Literature talks about lipocalin and what? Triglycerides, esters. But the main thing is what? It contains what? Fats and what? Triglycerides. Okay? Triglycerides. So that is the main component of the lipid layer. So let's now turn attention to the aqueous layer and the substances that the aqueous layer harbors or contains. It will interest you to know that the aqueous layer has electrolytes, proteins, and of course certain other substances that we spoke about later. So it contains what? Electrolytes, some solutes, and some other substances. Okay, so electrolytes, solutes, proteins, and other substances. Let's start with the electrolyte that it is rich in. So, notable among the electrolytes that the aqueous layer is rich in are sodium, chloride, potassium, iron, copper, magnesium, calcium, phosphate. So, these are the basic electrolytes that the telephone, the aqueous component, is rich in. I repeat, these include sodium chloride, iron, copper, magnesium, calcium, not forgetting that potassium is there, and we also have what? Phosphate. All right. So there are certain solutes that are also found within the telephone, the aqueous layer. There are certain what? Solutes. What solutes are we talking about? Notable among the solutes are urea, glucose, lactate, citrate, ascorbate, and certain amino acids. I repeat, the solutes include urea, glucose, lactate, citrate, ascorbate, okay, and certain amino acids. So I ask myself, what do amino acids help in forming in biochemistry? They help in formation of what? Proteins. Okay? And proteins help in production of what? Immunoglobulins. So by inference, the aqueous layer is also rich in certain immunoglobulins. Notable among them are immunoglobulin G, A, M, E, and D. Alright, again, there are certain antimicrobial agents that the telephone is rich in. These antimicrobial agents fight automatically and physiologically against any offensive microorganism. More often than not, you put your hand around your eye, sometimes in your eye, your hands may not be clean. You might have inoculated some microorganism into the ocular surface, but you will not have conjunctivitis. You will not have infection. Why? Because the telephone, okay, of course, we are talking about the aqueous layer, is rich in certain antimicrobial agents. Notable among them are lysozyme, beta-lysine, lactoferrin. Lysozyme, beta-lysine, and lactoferrin. Of course, there are also interferon molecules within what? The, the aqueous layer. The interferon molecules help fight against what? Viral infections. Now, let's draw our attention to the mucin layer. That So what does the mucin layer contain? Okay, so basically it contains what? Mucin. Okay, it contains what? Mucin. So basically, that is it. So let's turn our attention now to the functions that each of these layers provide to the eyeball, the eyelids, and the integrity of the physiology of the whole eye. So what are the functions of each of these components that we have been talking about? So, for example, when it comes to the lipid layer, okay, the lipid layer, I want to give you example of if you have two buckets of water, all right, two buckets of water, one has fat on top of it, the other one doesn't have any fat on top of it. Which one will evaporate faster? Okay, it's obvious. The one without fat will evaporate faster. So, what are the functions of the lipid layer of the telephone? It prevents evaporation of aqueous layer and maintains telephone thickness. So, the lipid layer, okay, it what? Retards or delays evaporation of the aqueous layer because it forms this foam here which doesn't make the aqueous layer evaporate faster. Okay. Number two, it increases surface tension of what? The aqueous layer. It increases surface tension so that tears will not easily flow down your cheek. Okay, so in other books you hear that it acts as a surfactant, allowing spread of the tear film. All right, so these are the two major functions. So let's talk about the middle aqueous layer. What is the function of the middle aqueous layer? Ladies and gentlemen, remember that the conjunctiva and the cornea are transparent structures. And when you talk about the cornea per se, it does not have blood vessels. It's a vascular structure. So how does it get its nutrition? Today we are coming to talk about one source. So the aqueous component, of course, contains water. Okay, hydrogen, two atoms of hydrogen, and one of what? Oxygen. So remember that the aqueous component, okay, it provides atmospheric oxygen to the cornea epithelium. It provides what? Atmospheric oxygen to what? The cornea epithelium. It has antibacterial activity due to proteins that we mentioned about. Okay, protein like what? Immunoglobulin G, A, M, E, D, and of course beta lysine, lysozyme, lactoferrin, and of course interferon. So it acts against infections on the what? Ocular surface. It also washes away debris and noxious stimuli and allow the passage of leukocytes after what? Injury. So it helps in washing away debris. Once in a while something falls into your eye, you don't do anything about it, but you realize that it has vanished. It is because the aqueous layer has washed that particle away from your eye. Last but not the least is that it provides a smooth optical surface to the cornea by abolishing minute irregularities. Okay, so it provides a smooth optical surface. Okay, so its presence provides smooth. It made the surface of the cornea and the conjunctiva become what? Smooth, so that if there are any irregularities, its lubrication alone will make the surface become what? Smooth. All right, so let's talk about the inner mucin layer. What are the functions? Okay, what are the functions of the inner mucin layer? It permits wetting. Okay, remember, generally the cornea surface or the epithelium of the cornea is what? Hydrophobic. Is hydrophobic. Hydro means water. Phobia means what? Fear. So the cornea epithelium or the most superficial part of the cornea doesn't like water. Alright? And the aqueous layer is rich in water and constitutes about 80% of the thickness of the tail film. So what does the mucin layer do? Okay, it converts the hydrophobic nature of the cornea surface to hydrophilic. Hydrophilic means it can have affinity with water, it can mix with water, it can accept water without any fear. Okay, so the mucin layer converts the hydrophobic nature of the surface of the cornea into hydrophilic, thereby allowing the aqueous layer to wet the cornea surface and lubricate it for better vision. Okay, yes, so it also acts as what? Lubrication. Okay, it acts as what? Lubrication, because the mucin layer itself is a lubricant. All right, so these are the major functions of each layer. Again, there is something I need to also add, that the aqueous layer also provides certain substances. Okay, the aqueous layer um let me tell you that the aqueous layer also is rich in what? Growth factors. Okay, growth factors and also pro-inflammatory cytokines. In growth factors and pro-inflammatory cytokines. Okay, so that is for your understanding. So those are the compositions. Now let's talk about types of secretion of the tertium. Types of secretion of what? The tertium. There are two major types. We have basic secretion of the tertium, okay, and we have reflex secretion of the tertium. So we have basic secretion and what? Reflex secretion. So when I talk about basic secretion, what do I mean? Okay, basic secretion here means that when you are sleeping, when you are at rest, okay, or you are at rest, basically, that is basic secretion, okay, without any stimulant, okay, towards your eye or towards your nasal mucosa. At rest, that's basic secretion. And that is what we term as the quantum being 7 to 10 microliters. Now, reflex secretion. What are the causes of reflex secretion of what? Tears. So, it can be from physical irritation to the cornea or the conjunctiva. So, if anything touches the cornea or the conjunctiva, it can be in form of injury, something scratching your ocular surface, or a substance dropping on the surface of your eyeball. It will act as what? Physical irritant. And that can cause what? Reflex secretion of what? Tears. And that will lead to excessive production of tears. And the range will be from 35 microliters and above. Another source is what? Psychogenic factors. Psychogenic factors that can lead to reflex tear secretion. Okay, what psychogenic factors? Okay, when you become emotional, maybe you have lost a dear one, so you are crying. You are very sad because you have really failed an exams. Okay, sometimes you are very excited. Okay, and tears are being produced. Or sometimes you are peeling onion. Okay, so all these are what? Psychogenic factors. Okay, that can lead to reflex tear film production. Another source of reflex tear film production in quantum is what? Bright light. If I shine very bright light into your eye, after a while, you start producing a lot of tears. Okay? Another one is mechanical stimulation of the nasal mucosa. Okay? It will also start what? Producing what? A lot of tears from your eye in terms of what? Reflex secretion. Reflex secretion. So, but there are causes of reduced reflex secretion. For example, when we put topical anesthesia in your eye, okay, it will blunt all the sensory innervations, okay, and secretion will reduce. And when we are asleep too, reflex secretion is what? Markedly reduced. So, I want to bring something to your attention, okay? Now that we have spoken about the functions, the quantum, the structures that it comes from, and so on and so forth. And what I'm come to talk to you about, we call it what? Regulation of tear film. How does the body as an entity contribute to increase or decrease production of what? Preocular tear film. For your information, okay, there's what we call regulation of tear film components. Regulation of tear film component. Alright, so there are two major sources that can have impact on how much tears or how much tear from our eyes may contain. One is called the hormonal control, and the second one is called neural control or neurogenic control. Hormonal control, there are certain hormones that may regulate production of what? Your tear film. For example, androgens are the prime hormones that regulate lipid production. Okay, we're talking about the lipid layer here. All right, so androgens are the main hormones that trigger production of what? Lipid in the body. Production of lipid and the lipid layer is not an exception. So remember that androgens as produced in the body, okay, all genders make androgens, but males make more androgens than what? Females. The most common androgen in the body is what? Testosterone, and is the most common androgen. And testosterone is produced in males and then by what? Females. Where do they come from? Okay, the adrenal glands produce androgens. Okay, testes in men produce androgens, and in females, ovaries produce what? Androgens. So, adrenal glands, both males and females have adrenal glands. Okay, that's number one. Number two, females have ovaries, which produce what? Androgens. And men have testes, which produce what? Androgens in form of what? Testosterone. Okay, so both females and males make androgens, and androgens are the major hormones, okay, which trigger regulation and production of what? Lipid. And in this particular case, which lipids are we talking about? We are talking about meibomian glands, gland of mole and gland of Zeiss. So, if androgen production is reduced, it will affect what? Negatively lipid production, and that can affect how much tears we produce in our eye. The second one is what? It has been found out that estrogen and progesterone receptors are in the conjunctiva and around the lacrimal glands. Estrogen and progesterone receptors are found within the conjunctiva and what? The lacrimal gland. So their receptors are found in the conjunctiva and what? The lacrimal glands. Okay? So estrogen and progesterone receptors are found in the conjunctiva as well as around the lacrimal glands. What does it mean? So the levels of estrogen and progesterone in the human body has effect and impact. So the higher their levels, the higher there could be what? Production of what? Tears. Okay? So which people have estrogen and progesterone? Remember that estrogen is produced by males and females, although females have more. Okay? Sources of estrogen is what? The ovaries and adrenal glands, also fat cells. Okay, but men also produce estrogen by their what? Testes. Okay, again, progesterone. Okay, progesterone is produced by adrenal glands. Okay, and testes in males, but of course in females by what? Ovaries. All right, so all these females in their menstrual cycle, when they are pregnant, and of course males, okay, depending upon how much of these hormones that we have in our body, it will have impact on the quality of our tear form. Again, regulation of tear form components, there are what? Neurogenic or neural factors. What do I mean? You should remember that the lacrimal gland has innervation from the trigeminal nerve, okay, the fifth cranial nerve. All right, but it also has mechanical influence, okay, from the facial nerve as and when the orbicularis contract. Okay, so that is what I mean by what? Neurogenic influence. So students, remember that if you are the quality of your term is not good enough, your eyes will be dry. Dry eyes can lead to what? Blindness. Okay, again, anytime we blink, remember that within 1 minute we should have at least 12 blinks. In other words, every 5 seconds it is good that you blink. Okay, the blinking mechanism, anytime you blink, it squeezes lipid from what? Meibomian glands and help in forming the lipid layer. Anytime you blink too, you have aqueous humor, the aqueous layer, being increased from where compression of the the lacrimal gland and its accessory lacrimal gland across and warfarin by the orbicularis, okay, oculi muscle, all right, and the mucin layer is also increased anytime we blink because there will be some pressure on the epithelial surface cells of the cornea, the conjunctiva, the goblet cells are there, the the lacrimal glands of Mans and Henle, they also squeeze more and help in forming the mucin layer anytime we blink. Okay, remember that when your eyes are dry, you can what? Be blind. So remember also that there's a substance called substance P, P standing for pain. So according to research, whenever we are in pain, we cry to secrete substance P as an evidence that we are in pain, and that is also found within the aqueous layer. Even we found growth factors over there. Okay, so students, remember that this is called the preocular tear film, and anything I've told you, try to read over it, listen to this particular message, watch the YouTube, and put down any questions if you have them. And once we meet in class, we are going to discuss about them. Until I see you again, continue learning hard. Okay.